Hello, everyone. We are the Python Menaces. I'm here with Jaime and Chris today, and today we'll be presenting our case diagrams. So first, starting off, we have our use case diagram. This is for our comic tracker application. Um, for this use case diagram, primarily first, we have our user, which is the comic book collector. This includes the use cases add comic, check for duplicate comics, search comic, view collection, edit comic details, add to wish list and view wish list, delete comic as well. And from these use cases, we can see the user interacts with each and every one of the use cases. Um, it checks for duplicate comics as shown and shows a relationship with the use case add comic since they work in tandem. And finally, the wish list features are shown as separate but still related functionalities and still connect back to the user.
All right. Next in our diagrams is the domain class diagram. The domain class diagram shows the main objects in our system and how they are related to each other. The four main classes in our system are the collector, the series, the issue, and the collection item. The collector represents the system's user. The series represents a comic series, and each series can contain multiple issues. The issue class represents the individual comic issues within a series, and the collection item represents a comic that the collector owns, including details such as quantity, condition, and date added. The relationships shown shows that a series can contain many issues, and a collector can own many items in the collection. Each collection item is associated with a specific issue. This diagram helps us model the system structure using object-oriented concepts, as you can see. Next in our diagrams is the system sequence diagrams for the create comic process. It shows how the user interacts with the comic track system step by step. First, the user enters comic data like title, issue number, and author. The system validates the data and returns a validation status. Then we have two possible outcomes. If the comic already exists, the system will display a duplicate error. If the comic is valid and new, the system asks for confirmation. The user confirms and the system creates the comic and returns a success message with the comic ID. This diagram focuses only on interactions between the user and the system, not the internal processing. We created three system sequence diagrams for the processes. The next one is the modify comic process. Same as before, it shows how a user modifies a comic in the comic track system. The user first searches for a comic by entering the information. The system checks if it exists. If it does not exist, an error is shown. But if it does exist, the system displays the comic details. The user enters modifications, confirms the changes, and the system updates the comic and returns a success message. As for our last system sequence diagram is the search comic process. In this one, this system sequence diagram represents the search comic process in the comic track system. Same as before, the user enters a search term, such as the comic title, issue number, or author. The system then processes the request and displays the search results. At this point, there's also two possible outcomes. If no matching comic are found, the system displays a no result message. If a matching comic is found, then the user selects a comic from the results and the system displays the comic details.
We'll be looking into the activity diagrams. So the first one we were taking a look at is the login one. We didn't include this in the previous diagram, but it's going to be included now just to show a little bit more of the overall scheme of our project. So first we have the login prompt menu, which takes us to test whether our login is valid. If our login is valid, we can successfully log in, and that's the end of the process. However, if our login is invalid, we have to test for two different things. First, we have to test whether the login is invalid or whether the password is invalid. In both cases, we can lead to either account recovery or account creation. In those both cases, we go back into the login prompt menu where we can test for a valid login again. The second process for the activity diagram that we're going to be taking a look at is the create item. So the first thing to create an item is we have to enter in item data. If our item data is valid or true, we can check for duplicates. Assuming that our item data is invalid, we're going to prompt for an error message and we're going to start the sub process all over again. If our data has integrity, we can check for duplicates. In duplicate existence, we have 4 different options that happen. Either there is no duplicate and we can immediately update the database, or there is a duplicate. If there's a duplicate, we have 3 sub processes that go on. We can either update the existing item, we can create a new item, or we can ignore the changes. Assuming that we're either updating or creating, these will both affect a database and it updates it. However, if we do not want to make any changes, we can ignore all changes and end the sub process there. The third activity diagram we're going to be taking a look at is the update and edit item activity diagram. When we're editing an item, we have to test whether the modifications, either singular or plural, are valid. If they are plural, we can go ahead and ask the user if they are sure about the changes. Depending on the response to this can either directly update the database or it can end the sub process there. However, if the item modifications are invalid, we're going to prompt the user for a quit menu. If they choose to quit, we can end the process there. However, if they choose to continue, we can continue to modify the system. The last activity diagram we're going to be taking a look at is the delete item activity diagram. So first we have to select an item. And we're going to ask the user whether they are sure of their choices, if they want to delete it or they want to exit out. If the user exits out, we can exit out of the sub process right here. However, if they're true, we're going to test for a second condition. If they have more than 1 item selected, we're going to ask the user of it. If they only have 1 item selected, we can continue and update with the database. However, if they have more than 1 item, we're going to ask them for a second assurance. The reason we're including this is to just make sure that, if you delete 1 item, it's not the end of the world, but if you're deleting rows and rows of items, it's a little bit of a bigger deal. So we need to check for assurance twice. For our first state diagram, we're going to be taking that to login state. We start off with this initial node up here, and we're starting off as logged out. When we're logged out, we can sort to submit our login, which authenticates. Either our login is valid right here, and it goes to the authenticator, in which we can end the sub process, or our login is invalid, and our login failed. From here, we can choose one of 2 routes. We can either recover our account here into this recovery mode, or we can create this account here in this registering mode. Both of these, recovering and registering, lead back into the logged out process. From here, we can re-authenticate, and we can start over this loop again, or we can fully log into our system. Our second state is for creating items. This initial node shows our connection to this creating item. The first thing we have to do is validate whether the creation of this item is valid. If it's invalid, we have to go back up here and we start this loop again. Assuming that our data is valid, we can then check for duplicates. So here there's 2 different options. Either there's a duplicate or there's not a duplicate. Assuming there is no duplicate, we can go ahead and update the database and finish the process. However, assuming there is a duplicate, we have 3 different sub-processes. So we either have to update the existing item, we can create the new item, or we can cancel the creation. Update existing, create existing, update the database, and cancel creation does not update at all. And they both end in this final process. Our third process that we're going to be taking a look at the state is the modify state. In the modify state, we have an item that we are editing. Assuming that our edits are valid, we can go either to the confirm update or the not confirm update. If we confirm our updates, we have to update the database. However, if our modifications are not confirmed, we can cancel the modifications and quit our process. However, let's say that we did have some modifications, but halfway through the modification process, the user decides that they don't want to modify it anymore. In this instance, we can go ahead and quit this process, which also leads us to cancel modifications. The last state diagram that we're going to be taking a look at is the delete state. In this, we are selecting in singular items or multiple items. The first thing we have to do is confirm whether the deletion of these items is valid. So we check whether we want to delete them. So in confirm deletion, we ask the user if they want to delete it. If they say no, we can cancel the deletion and end the process. However, if they say yes, we're going to check if they have multiple items. If they have a singular item, we can continue with the deletion and update the database. If they have multiple items, we can ask for a second confirmation. And if they confirm this one, we can also update the database. And if they don't confirm it, we can cancel the deletion right there.
And that was our presentation for our object-oriented models. And see you guys next time.
Bye.
Great.